Hello students, myself Amrita Roy. Today we are going to study the last part of Unit 1, Illumination, of the subject Utilization, Traction, Heating and Drives. Let us go through the contents. We are going to study about the basic principle and application of sodium vapor lamp, basic principle and application of compact fluorescent lamp, basic principle and application of metal halide lamps, LED lamps and neon lamps. So let us get started with the basic principle and application of sodium vapor lamp. Sodium vapor lamp is basically an electric discharge lamp using ionized sodium that is used for street lighting and other illumination. A low-pressure sodium vapor lamp contains an inner discharge tube made of borosilicate gas that is fitted with metal electrodes and filled with neon and argon gas and a little metallic sodium. So when current passes between the electrodes, it ionizes the neon and argon, giving a red glow until the hot gas vaporizes the sodium. The vaporized sodium ionizes and shines a nearly monochrome yellow. So we must remember that for a sodium vapor lamp, the gas color changes from beginning when it reaches the final color. So the initial color will be, that is when the lamp is about to glow, the beginning color or the initial color will give a red glow, and when the hot gas will vaporize for final glow, it will give a monochrome yellow color. That is when the sodium vapor will ionize properly, it will shine and give a monochrome yellow color. So the sodium vapor lamps have been used widely for street lighting purposes since the 1930s because of their efficiency and the ability of their yellow light to penetrate fog. So this is one advantage of a sodium vapor lamp, that the light intensity is so high that it can penetrate through the fog. Now in case of high pressure sodium vapor lamps, it has an inner discharge tube that is made of translucent alumina that can withstand the corrosive effects of a mixture of mercury and sodium under greater pressure and high temperature. So here for high pressure sodium lamps, it gives a whiter light and are used for extra bright lighting in places such as road intersections, tunnels, sports stadiums and other places where it is desirable to see a full spectrum of reflected colors. So here we have two diagrams. Left one is the low pressure sodium vapor lamp and right one is showing the high pressure sodium vapor lamp. So the low pressure sodium vapor lamp has a cap, a barium jetter, a stem, a low support sodium resistant seal, a cathode IR coating, outer bulb, upper support, discharge tube, sodium and a heat reflector. On the right hand side of the diagram of high pressure sodium vapor lamp, we are getting a jetter ring for basically maintaining a high vacuum. It is containing a hard glass outer bulb, quartz discharge tube, a sleeve protecting the support, lead-in wire or support and a screw base. Next is the basic principle and application of compact fluorescent lamp. A compact fluorescent lamp uses vacuum pipe which is principle-wise same to the strip lamps commonly known as the tube light. So the tube has two electrodes on both ends which is treated with barium. So the cathode is having a temperature of about 900 degrees Celsius and it generates a beam of electrons which is further accelerated by potential difference between electrodes. These accelerated electrons strike mercury and argon atoms, which in turn results in the rise of a low temperature plasma. This process initiates the radiation of mercury in ultraviolet form. So the tube's inside face contains luminophore, whose function is to convert the ultraviolet light into visible light. So this tube is fed with AC power supply, which facilitates the changing functionality of anode and cathode. The compact fluorescent lamp also consists of a switched mode converter. So it functions on a very high frequency and acts as a replacement of ballast, that is the choke and starter assembly. So the compact fluorescent lamps are being used in residential applications, replacing incandescent and halogen lights. So they provide relatively shadow-free lighting in residential applications, and because of their small size, they can fit nicely into scones, ceiling lights and table lamps. So here it shows the diagram of a compact fluorescent lamp. So the outer coating has a phosphorus coating, a base, a ballast, and inside between the electrodes an arc is here. The ultraviolet light is formed, which is vaporizing after vaporization of the mercury vapor, it is giving an ultraviolet light and finally into a visible light. Next is the basic principle and application of metal halide lamps. A metal halide lamp is basically an electric lamp that produces light by an electric arc through a gaseous mixture of vaporized mercury and metal halides. So, metal halides contains compounds of metals with bromine or iodine. In a metal halide lamp, the compact arc tube contains a mixture of argon or xenon, mercury, and a variety of metal halides such as sodium iodide and scandium iodide. The particular mixture of metal halides influences the correlated color temperature and intensity, making the light more blue or red, for example. So when started, the argon gas in the lamp is ionized first, which helps to maintain the arc between the two electrodes with the applied starting voltage. So when the heat generated by the arc and electrodes, then this ionizes the mercury and the metal halides into a plasma, which produces an increasingly brighter harsh white light as the temperature and pressure increases to operating conditions. So the metal halide lamps are used for general lighting purposes, both indoors and outdoors, such as commercial, industrial and public spaces, parking lots, sports arenas, factories and retail stores, as well as residential security lighting, automotive and specialty applications are further fields of usage. So in the given diagram we can see that it has an outer jacket, a bimetal switch, an exhaust tube, a fly wire, an arc tube, a jetter, a frame and a shell. Next is the basic principle and application of LED lamp. An LED lamp basically consists of a PN junction diode. It is specially doped diode and made up of a special type of semiconductor. So when the light emits in the forward biased mode, it is called a light emitting diode. When the diode is forward biased, the electrons and holes move fast across the junction and they combine constantly removing one another out. Soon after the electrons are moving from N-type to P-type silicon, it combines with the holes, then it disappears. Hence it makes the complete atom more stable and gives the little burst of energy in the form of a tiny packet of photon of light. So the main applications of LED lamp are, these can be used in home and industries. They can also be used in motorcycles and cars. They can also be used in case of mobile phones to display the message. So, and also at the traffic light signals, LEDs can also be used. So here we have the diagram for LED. So from the diagram we can observe that the N-type silicon is red in color and it contains the electrons. They are indicated by black circles, and the P-type silicon is blue in color and it contains the holes and they are indicated by white circles. The power supply across the PN junction makes the diode forward biased and pushing the electrons from N to P-type. So pushing the holes in the opposite direction. Therefore, the electron and hole junctions are combined and the photons are given off as the electrons and holes are recombined. Lastly, we are going to study about the neon lamp. Neon is basically used as one of the noble gases. So, in this case, there is an electrode at either end of the tube. So, a neon light actually works using either AC or DC. But if DC current is used, the glow is only seen around one electrode. AC current is used for most neon lights. So when an electric voltage is applied to the terminals, enough energy is supplied to remove an outer electron from the neon atoms. So if there is not enough voltage, there will also be not enough kinetic energy for the electrons to escape their atoms, and hence nothing will happen. So the positively charged neon atoms are attracted to the negative terminal, while the free electrons are attracted to the positive terminal. These charged electrons called plasma complete the electric circuit of the lamp. So the neon lamps are commonly used as the low voltage surge protectors, but they are generally inferior to gas discharge tube surge protectors, which can be designed for higher voltage applications. So in the diagram we can see the neon lamp contains a pipe, a gas envelope, a glass envelope, electrodes, a pinch and leads, and inside it is filled with neon gas. Thank you. So we have finally completed Unit 1 of Illumination successfully.